Alright, in this video here we're going to talk about the vertical line test, which is actually a pretty simple thing to do. The hard part sometimes is people just remembering how to apply the vertical line test and what the results mean as far as whether something is or is not a function. But the vertical line test is a test we use on a graph to tell whether that graph represents a function or not. Right? So again, the vertical line test is real easy to use. As long as you understand what you're doing. So my purpose in this video is one, to point out to you what the vertical line test is and to show you a couple of examples of using it, but also to help you understand why the vertical line test tells you whether or not something is a function. Because if you understand that part, then it just makes a whole much more sense, and it kind of connects with some of the other things that you've learned about functions. All right, so what the vertical line test says is a curve in the coordinate plane is a graph of a function if and only if no vertical line intersects the curve more than once, right? So a vertical line, remember, vertical means straight up and down. So a vertical line represents one single x value, right? Remember, if you haven't seen the video I did on the equations of horizontal and vertical lines, the equation of a vertical line is x equals some number, right? Like x equals 5 or x equals -2. If you graph those functions, they're vertical lines straight up and down. Right, so that vertical line represents one single x value. So when you're looking at a graph, that vertical line is the single x value. If that x value hits the graph one time, well, then that means for that x value, there's only one y value, which means there's only one output for that x value. And if you haven't watched the video I did on the definition of a function, for something to be a function, then for each input value, each input can only have one single output associated with it. Right, so that vertical line, if it touches the graph one time, then for that one input, there's only one output. If that vertical line hits the curve more than one time, well, then for that one input, there's more than one output, and now it's not a function. Right, so I hope that made sense, but when I do a couple of these examples here, I'll kind of explain it to you again to make sure you understand what the vertical line test is actually telling us. Right, so basically, when you use the vertical line test, you're looking at the graph of something. If you can draw a vertical line anywhere through that graph that hits the graph more than once, it's not a function. Right? So for this first one here, example A, where we have kind of like an oval type shape, well, it's pretty clear that I can draw a vertical line in a lot of different places. I'll just put one right here. And that vertical line hits that graph 2 times, therefore, it's not a function. Right? The vertical line test is as simple as that. I draw a vertical line, it hits that graph more than once. That's not the graph of a function. Right? Now again, what that means, right? This vertical line represents one single x value, right? One input value. For something to be a function, each input can only have one output. Well, this input, this x value here, has 2 different outputs. It has this y value up here and this y value down there. So if that one input has 2 different outputs, it's not a function. Right? That's why the vertical line test works. Because the x value, the vertical line represents one x value, one single input, and anytime you have an input with more than one output, meaning more than one y value, it's not a function. Right? Again, if you don't quite still understand what the definition of a function is, I made a video about the definition of a function, so you might want to go watch that, where I go a little bit more in depth into the definition of a function. But what I just said there is basically what it is. For each input, you can only have one output. If you have more than one output, it's not a function. Right? So for example A here, by the vertical line test, this is not a function. Right? The vertical line hit the graph more than once. For example B, well, if I draw a vertical line through this graph, I'm only going to hit the graph one time. For that one input value that represented by that vertical line, it only touches the graph once, so there's only one output value. Now, is there anywhere on that graph where if I drew a vertical line, it would hit the graph more than once? Because it only takes basically one bad thing to spoil the whole thing. Right? In other words, if I can draw one single vertical line anywhere on that graph that hits the graph more than one time, the whole thing is not a function. Right? Even though I can draw one over here that only hits it once, if I can draw another one over here that hits it twice, not a function. Right? It only takes one single input with more than one output for the whole thing to not be a function. But in this case, no matter where I draw a vertical line, it's only ever going to hit that graph one time. Right? So for example B here, this one is a function. Right? By the vertical line test, anytime I draw a vertical line, it hits the graph once, therefore I have a function. Right? Again, no matter what input value I choose, no matter where that vertical line is, there's only one output, right? It only hits the graph at one point, so there's only one y coordinate associated with that x coordinate. All right, so that one is a function. Example C down here, kind of a weird looking graph. Is it a function? It is, right? No matter where I draw a vertical line here, I'll draw a few of them just to kind of point it out, but no matter where I draw a vertical line, it's only ever going to hit that graph one single time. Right? So for each input value, for each x value, for each vertical line, there's only one output value. There's only one y value. That vertical line only hits the graph one time, therefore it's a function. Right? And then example D, pretty obvious. I can draw a vertical line through here that actually hits the graph 3 different times. Right? So for that one input value, for that one x value where I drew that vertical line, there's actually 3 different output values. Right? There's this y value down here, there's this one up here, there's that one up there. If one input has more than one output, it is not a function. All right, and remember, it only takes one input to make it not be a function. It only takes one vertical line. Like I could draw a vertical line over on this side that only hits the graph once. So I say, well, that vertical line hits it once, so it is a function. No, but if you can draw a vertical line somewhere else that hits more than once, then it's not a function. The whole thing is not a function. All right, so since I can draw a vertical line here that hits that graph more than one time, in this case 3 times, then that whole thing is not a function. All right, so that is the vertical line test. Like I said, it's real simple to do. There's not a whole lot of work involved in the vertical line test. You just look at a graph. You can even mentally draw a vertical line through and say, oh, that vertical line hits twice or 3 times. It's not a function. Or no matter where I put that line, it only hits the graph one time. Therefore, it is a function. All right, but again, if you understand why that is, as far as the x representing the input and the intersections with the graph representing the output values, and how that relates to the definition of a function where each input only has one output, if you understand all that or that part of it, it just helps your overall understanding of what you're doing, and you see the connections between these different things, and it makes the stuff that comes later a lot easier to comprehend. Right. So hopefully you understood all that stuff I was saying, relating this to the definition of a function.